I just wanted to take a moment and thank you for supporting the site with your subscription. You're making this type of content possible, and I really appreciate it. Alright, so let's dive in. I thought it might be fun to mix things up a little by creating an episode series around building an audio-to-text transcription service. The product idea is pretty simple. You'll upload your audio files to this website as an input. Then on the backend infrastructure here in this black box, we'll process and transcribe these uploaded audio files, and then a short time later we'll send an email with the transcribed text files as an output. The goal of this episode series is to architect and build out what's happening behind the scenes here, on the back end in this black box, that's enabling this simple customer workflow. By the time we're done, we should have a simple application that delivers state-of-the-art automated audio-to-text transcription with high accuracy and lightning speed. As you can see, this will involve a bunch of different containerized services, a database, blob storage, a worker queue, and lots of remote transcription API calls. My thinking here is that I want to replicate what a real company might be dealing with, and hopefully learn lots as we work through this together. I'm positive we'll make mistakes and we won't get everything right the first try, but that's actually kind of a good thing, as we can build on these ideas in future episodes. For example, I could see us looking at lots of different topics around logging, monitoring, cost modeling, and probably lots of infrastructure optimization bits, just to name a few. Additionally, when you're working on these types of things, there's often pros and cons to each path you choose, and so we can sort of chat about this as we're working through it. It should be pretty fun, as this is a mix of business ideas, some programming, and lots of back-end operation stuff. It's almost like a Venn diagram, as we'll be briefly touching many topics in these core areas. I find it useful to work on these types of projects from time to time, as it sort of gives you a point of reference for what other groups in your company likely care about. It sort of puts you in their shoes. Alright, so I've broken this episode series into 3 parts. I picked the name Phonic Tonic as it sounds kind of funny, it rhymes, and the word phonic is related to the sound of speech. And then we'll be adding some machine learning tonic into the mix. I have to admit this name is mostly BS though. I was really searching around for names that hadn't already been taken, especially domain names. And I came up with this one. It's sort of a play on words after looking through a thesaurus. In the first episode, which you're watching now, is where we'll chat about the general idea, walk through the workflow step by step, we'll sketch things out, and chat about the back-end workflow. We'll also chat about the competitive landscape and pricing. Then we'll look at a demo where we actually transcribe something at the command line via remote API. This episode covers the core idea that we're going to be building everything on top of. In the second episode, we'll design, code, and containerize our website, media transcoder, audio transcriber, and our email notification services. There will also be a bit where we chat about what a data model would look like for this thing, and how I typically approach that. We'll also wire these containerized services up to our backend database, our storage system, and our worker queue. This episode will likely be super technical and very fast-paced, as we have a lot of material to cover. You'll also get all the code as we work through this together. Finally, in the third and final episode, we'll round things out by looking at what a product checklist looks like. And we'll chat about payment options, and mostly just try to sand off any rough spots on our way to a minimum viable product. The end result that I'm shooting for here is that we should be able to launch something that regular people out on the internet can actually use to quickly transcribe their audio files into text on a self-serve basis. So why pick this idea and create a website like this? What's so important about audio-to-text transcription services? Well, this idea stems from a trend that I've seen developing. I think there's an opening in the market for a dead simple, fully automated transcription service that's self-service, super cheap, fast, and gets you close to 95% accuracy. Sure, the end user is going to have to put in a little bit of elbow grease to clean up the transcription, but it's going to save them tons of money. Let me explain. So I read this book a few years back about the founding of Intel and how they noticed something that no one else did. Basically, that integrated circuits were going to be huge and they needed to put all their effort into that area. I think there's a similar mini trend happening today when it comes to the latest advancements in machine learning in terms of speech recognition. I highly recommend reading this book, by the way. It used to be the case that you'd have to spend megabucks and use a custom-trained speech recognition engine by a company like Nuance. But just within the past 3 or 4 years, IBM released a general transcription model that works across lots of speakers, and it's pay-as-you-go. Then Google released one 2 years ago that does something similar. Finally, AWS released theirs last year. These types of APIs are what's powering all the Alexa devices and Google Assistant devices out there. So these tools are becoming much more advanced by the day as folks at these companies are gathering more data and refining things. In my opinion, they're only going to get better and the price is even going to drop further. The key point here is that these companies are allowing the general public access to these highly advanced models. And in my opinion, the accuracy is only going to go up, and the price is going to drop further down. And they'll likely get much quicker too as the algorithms and hardware supporting this gets tuned. So here's how I see things. By the way, I'm not an expert at all in this field. It's just something I've done a bit of research on and built a few prototypes. So say 15 years ago, if you wanted to get something transcribed, say closed captioning for a movie or TV show, or maybe medical records, etc., you'd have to pay big bucks to a professional transcriber. The next iteration or evolution of this was that software came along to assist these professional transcribers. This was software like Drag and Dictate or other custom stuff from the company Nuance to help automate much of this manual work. But this was pretty cumbersome, and it had to be specifically trained for one person's voice, and the accuracy was not all that great. Well, just in the past couple of years, things are getting way more advanced with machine learning models, and it's totally generalized and works across lots of different speakers. You don't have to train for a specific person's voice anymore. Accuracy for these machine learning models is shooting through the roof too. This software used to have massive problems with speakers with accents and things like that. There's also much more advanced tooling around formatting of transcripts for specific use cases. Things like medical templates, punctuation, legal jargon, and lots of other stuff. In my opinion, this advanced technology is increasing the professional transcriber's productivity, but it's also causing loss of work on the high end, since they're essentially now proofreading what the computer is doing. So just within the past 2 or 3 years, developers can now sign up to IBM Watson, Google Speech-to-Text, or AWS Translate and get access to these really advanced tools for just fractions of a penny per minute. So let me add some numbers. For the first 2 use cases here, it's not uncommon to pay $100 plus per hour for a professional transcriptionist, with a turnaround time of a few days. If you wanted to rush that job, think about doubling this rate. With multiple speakers, add more money. Does the speaker have an accent? Add more money. You sort of get the idea. It becomes pricey really quickly. Now, lots of these existing transcription companies are integrating these advanced machine learning models as sort of a pre-processing step before the transcription sees it. So they can now process way more jobs, but the price per job is also going way down. Turnaround times are also pretty much the same, as now they can accept more high-priority jobs on the front end. Right now, I'm starting to see a lot of startups leveraging these new APIs from IBM, Google, and AWS to further drop the price and speed things up. I should point out these APIs are only accessible programmatically. So the missing piece of the puzzle here is for someone to write a super simple way of processing jobs through these APIs. Well, this is what I wanted to focus on in this episode series. I suspect these prices can drop even more, and the turnaround time can be dropped significantly for most of this. I had sort of a startup idea around this, and that's where the idea for this episode series came from. In that these large companies are going through a massive 10x change both in price drops and turnaround times, given the latest advancements in these cloud transcription offerings. That's why I wanted to build this thing out. To help explain this, I put together a simple spreadsheet that runs through some of the numbers. This is super high level, but it helps to paint a picture a little better of what these machine learning speech recognition tools are enabling. So the first column here shows the raw cost of using tools like IBM, Google, and AWS Translate. The per minute cost is roughly about 2.5 cents, and that works out to about $1.44 per hour of transcribed audio to text. Now, most of these cloud-based transcription services only accept transcription jobs in a specific audio file format. So we'll likely need to run a bunch of back-end infrastructure that accepts jobs, transcodes or converts uploaded files from one format into one that'll work, submits and babysits these jobs, and formats the results into something human readable. This is where our price comes in. So you can play around with the numbers here and sort of figure out how much you'd need to charge to make it worth your while, as you'll need to pay for infrastructure costs, wages, fraud, taxes, etc. This is pretty much like rough napkin math here, but it sort of helps to paint a picture of what's going on. So we'd need to process around 5,000 to 7,500 hours per month to make pretty decent money. Granted, this only works if it's a 1 or 2 person company, but you don't really need much since the operational overhead of running this type of site is pretty low. So we need to charge around $6 per hour to cover our costs. This gives me the sense that there's totally room for smaller companies and startups to start nibbling away at the current market share. Even if we bump our prices up a little, say to 25 cents per minute, that gets us into the $15 per hour range. This is actually what I found a few startups charging. I think we'd need to work the numbers quite a bit more and start profiling workloads to figure out the exact cost per job in terms of compute, storage, bandwidth, But from what I see here, this mostly makes sense. I know this is pretty far out there from my usual topics, but honestly, I think this is a useful topic to discuss as most startups and companies operating in the cloud will typically look at this kind of stuff. I've often been asked to create a budget for a particular workload and give cost estimates at different traffic points. This is actually a really critical skill to have, even if it's just estimations and then you can refine the numbers as you get more data. I think it's super useful to be thinking about this kind of stuff. I've added the link to this spreadsheet in the episode notes below if you want to have a look too. So say we're charging something between $6 and $15 per hour of processed audio. Let's flip back to the technology comparison page for a sec. So we're still pretty much state-of-the-art on price, automated accuracy, and job turnaround time. This is all assuming the customer wants to spend a few minutes of their own time proofreading and doing a little formatting. But I suspect tons of people will be willing to do that for the price difference. I think this will open up tons of new customer use cases since transcription is now super cheap. So they might decide to transcribe things they otherwise wouldn't have because it was too costly. My thinking is that we could probably drive the cost down even further as we learn the business and automate things. So this is my very long-winded explanation of where the idea came from. I was mainly thinking about the impact of machine learning tools on existing companies and if there was any opportunities there. But there are a few big problems with this idea though. To hit these kind of numbers, we'd have to get a lot of new customers through the door each month, and that's a costly and complex problem. Also, what happens when these established companies create a budget option and offer something similar to what we're doing? That's why I don't really want to go full tilt into this idea, in that it seems pretty risky and you're likely going to face tons of competition as other startups try to capture this market. So I thought it would be kind of cool to use this idea as a teaching tool, but also launch it for real at the same time so that we can sort of learn about this together. Please let me know if you have any ideas around this. It would be nice to sort of tap into the hive mind here. All right, so let's chat about competitors for a minute. If you search for audio to text transcription, you'll instantly see lots of offerings with a wide range of pricing. Companies offering transcription from 20 cents per minute all the way to $1 per minute plus. We already looked at how we could likely charge something in the range of 10 cents per minute. So one of the big companies here seems to be Rev.com, where they'll have a professional review your transcript before sending it over, which is pretty cool, but costly. The next one is Trint.com, and they appear to be closer to our idea by just offering an automation tool that gets the transcription done quickly and cheap, but you're left to do the final editing yourself. They seem to have a pretty polished tool too. Finally, there's a whole slew of megacorps that are doing most of the medical transcription stuff out there. I think this is actually a really good idea, as you likely want to have a human in the loop looking at medical terminology and medical dosages and things like that. A good hint here is that they don't even list the prices, as you can guess it's probably megabucks. And this isn't our target market at all. I don't want to go after that. I was sort of thinking about maybe students that want to transcribe a lecture, maybe podcasters. I suspect there's a whole bunch of office folks that want to transcribe meeting notes and things like that. All right, so that's my brain dump on how I see things today and what I think about in terms of this idea. So what does a product and back-end architecture look like for actually processing these types of transcription jobs? Well, as I mentioned before, I sort of envision a website where you enter your email, you drag your files over, then you click submit. On the back end, we probe these files and calculate the audio length, and we come up with a cost and ask the user if they want to pay this. If they say yes, we process the jobs on the back end, and then we send them an email link with the results shortly after when the jobs are complete. You might be thinking, why the delay here? Why not just do it instantly? Well, most of these cloud-based transcription services take a few minutes to process the jobs, especially if they're really long audio files. So we need a way to accept jobs from customers, process them, babysit the transcription process, and eventually return the formatted process results to the customer. So let's walk through how this would actually work step by step. So a new user shows up at our website, hitting our main web service. They enter their email, they upload their files, and they pay. We're flushing all this data into a SQL database for order tracking, uploading the audio files to cloud storage, and then we're submitting a job into a queue for processing. Episode 59 on RabbitMQ might be a good refresher on worker queues here to add some background context if you're new to that. I mentioned before that these cloud transcription services are super picky about what formats they'll accept audio in. So say we have a lawyer who recorded a deposition and they want to get a text transcript of that. Well, we'll likely need to strip out the audio tracks from that video, convert the audio into a format that the transcription service will accept, So the next worker in the queue here is this transcode service that fetches audio files from storage, converts them into acceptable formats, and then saves them back to cloud storage using a new file name. Then we submit a task into the task queue for this audio file to be transcribed. Our transcription worker here grabs the task out of the queue and submits a job into the cloud provider's transcription API. When it makes that call, it passes a configuration and a link to where our newly created media file is sitting in cloud storage. Then the worker waits and sort of babysits this transcription job until it's complete. It might take seconds or it might take many minutes to complete. When it finally completes, we save the results back to cloud storage and we update the database with the final status. Finally, another task is submitted into the queue to notify this worker service here that will email the customer and say, hey, your jobs are now ready to be picked up. So I don't think there's any right or wrong way to do this. This is just what I've come up with. I'm sure if you were to go and look at a lot of these companies, they'd be doing something similar to this, but it wouldn't be exactly the same. So this is the end-to-end workflow that we'll be building. I wanted to use this decoupled task worker queue model because we have lots of background things running in parallel that will take a variable amount of time to complete. Since each step is fairly isolated, it gives us more operational flexibility too. This architecture also scales really well. But we'll cover this heavily in the next episode and walk through sort of the pros and cons of what we're doing here. I think the thing to keep in mind is that there's nothing too complex on the back end here, but ultimately the customer doesn't even care about any of this. From their perspective, this is pretty much a black box. So we just need to make this as simple and easy to use as possible so they'll actually use our service. That's why I wanted to focus on a minimalistic front end that would make it obvious what they're supposed to do. Let's get back to that Venn diagram from earlier. Just like many customers, I find that many folks inside your company will also think of what you're doing as a black box. They don't care if you're using containers or not, Kubernetes or not, using a worker queue or not. They don't care. They just want it to work, be reliable, and get customers through the door to give the company money. It took me many years to learn this fact. The company only really cares if this positively or negatively impacts its bottom line. This little piece of insight can be extremely powerful though. Take this example. Say a customer pays you $7 and $3 automatically goes out through your black box into other people's hands, like the cloud provider, payment processor, your wages, etc. Your company only gets to keep $4 of that. If you think about this from a management or executive perspective, they're always trying to get better returns. They might see charging the customer more as an option or adding additional service plans. They might even see outsourcing pieces of your black box as an option too, all in an effort to increase what's coming back to the company. This isn't really related to the episode, but I thought of it while working through this. So I wanted to mention a few useful ideas for getting good performance reviews at work. Folks in the operations space have a unique perspective as we totally understand what's happening behind the scenes here. This is where you can really shine on your performance reviews if you think of things a little bit from a management or executive perspective. How can we increase the value to the customer or company? Maybe you can come up with some sort of impact statement on how you save the company a bunch of money. Or maybe you decrease customer turnover by fixing some back-end component. Thinking from this type of perspective and putting these types of statements into your performance review can really go a long way to making you more money. I found that focusing on the impact and metrics that increases the company's bottom line goes really well. I wanted to share a few articles that really opened my eyes to this line of thinking. One's called Don't Call Yourself a Programmer, but this also heavily applies to DevOps folks too. Here's another one on how to make yourself more valuable to the company, basically using your unique knowledge. There's also another one by the same guy, Patrick McKenzie, also known as Patio 11 on Hacker News, around salary negotiations. This stuff is super valuable, and it personally worked really well for me when I applied it. I just figured since we were chatting about sort of our fictitious company's financials and how we're looking at the back end, you probably already have ideas of, hey, maybe you could optimize this to save a little bit of money. This isn't something that you're going to likely use right now, but it really helps to know since you can create sort of an action plan for your next review cycle. I thought this topic was sort of relevant since we're looking at this transcription project sort of from a startup founder perspective. And you can easily see, hey, we need to reduce cost in a particular area to make us competitive. And so if you apply that same sort of perspective to your current company, maybe you can get some sort of financial benefit out of it if you can save the company a bunch of money or maybe increase a revenue stream. And hopefully you're wildly successful with it. Anyways, that wraps up what I wanted to chat about. Hopefully you'll find this episode series really useful. I really think it's worthwhile since you'll likely be able to apply a lot of this stuff elsewhere. But before we wrap things up, I wanted to show you a demo, or sort of a proof of concept, where we'll actually get an audio file transcribed via one of these cloud APIs. So let's head over to the console. I'm just going to copy and paste a command here that's going to call a Google Cloud Transcription API. You can see I'm using curl and I'm calling the speech API. I'm composing a request with the following configuration. I'm setting the audio encoding to the WAV format and the language to US English. This option here allows you to tag different speakers in an audio recording. Say, for example, you might see multiple persons talking in an audio file. What this transcription API can do is it'll actually tag people as speaker 1 or speaker 2, which can be fantastic for interviews. To me, it's kind of crazy that a computer can automatically tag individuals like this. Next, you can specify the machine learning model that you want to use. And there's a few that are tuned for different use cases, say for example phone calls or videos, but I've typically gotten the best results with the video model here. This line tells the API that we want to get word boundaries. This will give us the time codes of when a word starts and when a word stops. This can be really useful if you want to generate, say, closed captions or something like that. This word confidence will score each word, providing a ranking using the model's confidence of what it thinks it understood here. Next, we ask the API to automatically add punctuation for things like capitalization, commas, periods, etc. This is pretty cool since the model will guess what punctuation needs to go where. It's not perfect, but it can help speed things up when you're proofreading and generally correcting things. Finally, we tell the speech API where the file is that we want it to transcribe. In my case, the audio file is sitting in a storage bucket, and the audio is from episode 54. Alright, so let's run it. The only output we get is this JSON object with a job name or a job ID. So I'm just going to copy and paste another command and use that job ID as input. Again, we're calling the speech API with the curl command, and we've pasted that number here. This is the job ID or job number that we got as output from the previous command. So let's run this to check the status of our transcription request. And we get back this JSON object. For our job, we're only 18% complete now. I'm just going to pause the video as this is going to take about 5 minutes to complete. You can keep running this command continually and eventually you'll get the results. So I started the video again. What I've been doing in testing is I just redirect the output of this command into a text file, where I can then look at it with a text editor. By the way, the audio that we processed was about 7 minutes long and it took about 5 minutes to process it. And the job cost about 17 cents based off our numbers in our spreadsheet. So I think it's well worth it since it might have taken a long time to do this manually. All right, so we have our file saved here. Let's just check the size. In case you're wondering, it's about 1.6 megs. Let's use the head command to grab the top few lines of this file to see the job start and stop times. So you can see it's 100% complete and it took just shy of 5 minutes to process this from start to finish. So you can sort of envision for a really busy transcription site, they're likely running lots of these jobs in parallel. So that's why having a worker queue can be really useful in that you can have a bunch of workers sort of babysitting all these jobs. So let's use the less command to browse through this file. By the way, I'll post a link to this raw file in the episode notes below if you want to have a look through it. So in this file, you'll see tons of JSON blocks that represent transcribed text from the audio file. You can also see there's punctuation too, capitalization, commas, periods, etc. This was all guessed by the machine learning model, which is pretty crazy. Then if you scroll down here, you can see each word is broken out with a start time and stop time, along with a confidence score. Each word throughout the transcript will have something like this. So depending on how long your audio file is, this text file could be quite large. Actually, let's jump back to the command line and see how many lines are in this file. Yeah, so there's roughly 52,000. So this is the speech transcription API in a nutshell. The IBM Watson one and the AWS Translate one are pretty much the same. As you can see, this isn't really user-friendly from a non-technical person perspective. This is why adding a super simple user interface here could be game-changing. You just enter your email, drag over a few files, and click submit. In the background, we'll coordinate all the file processing, job shuffling, and just send out the processed and clean text to our end customers. All right, well, that's it for this episode. Please let me know what you think of these types of projects. I also wanted to complete the one from episode 51 too, around building a carpooling service. I think these episode series helps to add some variety from the week to week, and it helps to mix things up a bit. All right, I'll see you next week.